Hello, algebra students. Mr. Lawrence here, and we're going to be doing some story problems using these systems of equations. And we're going to start with what are called current problems. And these are super simple. They are. You've got to read carefully. And you know what? Some of you really have been slacking on your homework. You're not doing the problems, and then you're wondering why you're getting such poor quiz grades. You've got to do the problems. The only way you're going to learn is by doing. If you want to learn, you want to understand without doing, I don't think it's going to happen for you. I think you're going to end up failing this quarter. I hate to see that. So before we actually get to the current problems, I have to ask you, what is speed? And no, I don't mean how fast something is going. I mean, yeah, that's a definition of speed, but we know another definition of speed. I mean, from your science classes, you know, they do this thing, and I'm not a big fan of it, but that doesn't mean it's bad, where you go distance equals speed times time, right? Or you could use the different version of it, speed equals distance divided by time. And that's going to be super important for us. Speed is the distance divided by the time. Say that with me. Speed is the distance divided by time. I can't hear you. Say it louder. Speed is the distance divided by the time. We're going to use this fact, okay? We're going to use this fact. Now, one other thing you need to keep in mind is that if you add apples and apples, you have to get apples, okay? If I add porcupines and porcupines, I have to have porcupines, all right? So let's see how this is going to play out. Remember, speed is the distance divided by the time. Okay, this problem says a boat travels downstream with the current for 12 miles. Hey, that's a distance, isn't it? I'm going to mark that with a D, okay? In 3 hours. Hey, that's a time. The trip upstream against the current takes 4 hours. There's another time right there. What is the speed of the boat in still water? What is the speed of the current? Well, it looks like I need to figure out the speed of the boat. Speed of the boat, let's call it B. Now, the speed of the current, let's call it C. You know, the current is how fast the water is moving, right? Now, if I'm going with the current, that means the current is like pushing me from behind. So it's going to be adding to my boat speed, or the boat speed, I should say. Now, what does that need to equal? Well, this is the speed of the boat, and this is the speed of the current. That's going to need to equal a speed. Well, what's speed? Speed is the distance divided by time. So with the current, the distance is 12 miles. What's the time with the current? 3 hours. Now, I know some of you are going, well, why didn't you use 4? Well, it says with the current. The boat plus the current, meaning the current is helping the boat, is 12 over 3. It takes 3 hours. Now I'm going to simplify that equation to B plus C equals 4. All right. Now, I know there's another trip where you go against the current. So the boat is going to be working against the current, which means the current is going to be taking away from the boat's speed. Okay? The distance will be the same, 12 miles, because it's the return trip. And this time it takes 4 hours. And so I'll have B minus C equals 3. Now, this right here, this system, is yelling at you, hey, look over here. I'm an elimination problem. So we're going to add these two equations together. And we do, we're going to get 2b. The c's are going to cancel because one's positive, one's negative. And that's going to equal 7. And if I divide b by 2, or 2b by 2, and that by 2, I get the boat speed is 3.5 miles per hour. That's a pretty slow moving boat. Yeah, I gotta admit, that's pretty slow. Now to figure out the current speed, I could take 3.5 plus c equals 4. I think most of you could tell me right off the bat that c is going to be 1/2 mile per hour. And there's your current speed. All right, let's try another one with these. And don't worry, we're going to get lots of practice with these. Ooh, I didn't make that very small, did I? I had intended to. Let's see if I can make that a little bit smaller so we can see the problem while we get some work. Let's see here. Okay, This story says Benny rides his bike 48 miles. Oh, there's a distance. Let's mark it. Distance. Excuse me. To a friend's house. He has a difficult time because the wind is blowing in his face. The trip takes 8 hours. There's time. The return trip is much easier because the wind is at his back and only takes him 6 hours. There's another time. What is the speed of Benny? It's still air. At what speed was the wind blowing? Well, let's see. I've got Benny's speed. He's out riding his bike. So there's the bike speed or Benny's speed. In the first equation, he's having a tough time because the wind's in his face. The wind is going to be slowing him down. So I'm going to take away the wind speed from Benny's. It's going to be reducing his speed. All right. I got a bike speed or Benny's speed minus the wind speed. That has to equal speed. What is speed? Speed is distance divided by time. What's the distance? 48 miles. How much time does it take? Well, against the wind, it takes 8 hours. Simplifying that equation, I'll get B minus W equals 6. Right? Okay, now, then he does the return trip, but the wind is at his back, so now the wind's helping him. The distance is the same, but since the wind is helping him, it only takes 6 hours. So I'm going to get B plus W equals 8. And again, this is a great problem for elimination. Do this by elimination. I'm going to add the two equations together. Get 2B, the W's will cancel, and I'll get 14. And divide by 2, B is going to equal 7. So Benny's speed is 7 miles per hour. All right, so if I do 7 plus W equals 8, well, you could probably see that W is 1, but if you can't, subtract 7 from both sides, and W is 1. So then the wind speed equals 1 mile per hour. And there you go. All right, I don't think I'm going to do any more examples. We're going to get some practice with these in class tomorrow. That's it for today. Mr. Lawrence signing off. Have a good night, everybody.